Hey guys, how is it going over there? We're going to be doing something very astonishing in this particular session. And I'm going to be training a machine learning model that's going to be wrapped in object-oriented programming. So over the course of an hour or two or thereabout, we're going to be setting up this project. And I'm going to be performing a lot of things in this project. Probably I'm going to start by using a data set, an Anaemia data set, so to say. And of course, we're going to be performing some kind of data cleaning inside of the data set. We'll check the data set, then we'll perform some kind of, maybe we're going to also use splitting. We're going to perform some splitting. Then we'll train the model, then perform some cross-validation using column transformers. And then, of course, we're going to perform hyperparameter tuning. We'll save our model and also make a prediction. So everything we're going to be doing in this particular session today is going to be built from the scratch. And I'm actually looking at you having your in my machine learning catalog. So let us get started. And if you would want this video, you want to support this particular channel, there's wanting to make a prayer for this channel. How do you make the prayer? The prayer can only be made by just drop a like, subscribe, and of course, it's definitely going to be the best. So let us get started, and that's it. So usually in my traditional, maybe if I want to do kind of some traditional programming, the first thing I want to do is to download maybe VS Code, your IDE, where you're going to run your program, and then you have your, maybe you have your other dependencies that you're going to install, and you get your data set and all of that. So how do we get our data set? Of course, we go to cargo.com, and when you go to cargo, of course, that's where you can get the data set and perform some kind of prediction, visualize your data set, do a lot of things and all of that inside of it. So we're going to be jumping straight right up. I'm going to open my VS Code, and of course, now I already created a file. So, but if you have a blank sheet, particularly you're creating yours, you could just go to open folder, and then you can create any folder of your choice. And of course, that's definitely going to work. But I already have mine, and I've created mine as practice folder. And I'm going to just create a file. I'm going to call this file Anaemia .interactive Python notebook. So this is the extension for probably if you're running on, I'm going to say maybe if you're using the IDE, maybe you're trying to perform any kind of machine learning operation in your Jupyter lab and Jupyter notebook. Of course, you're going to use the extension. If you want it to be a Python file, you could just use maybe anaemia.py. Okay, that's going to give you a Py file. If you use .js, it's going to give you a JavaScript file. But if you use .cpp, it's going to give you a C++ file. .c is going to give you a C, and so forth and so forth. Okay. So I'm just going to clean that. Okay. Now I have my recent installed at Python 3.13. So I could just start by saying print welcome to research. And of course, that should print. And I could just confirm that I have my dependencies. So, okay, yeah, that's printed already. All right, so that's cool. We are good to go. Now, the first thing we are going to do is that we might want to install all the necessary dependencies that we want to use in this project, okay? By that, what I'm trying to talk about is there are some certain, packages that are definitely going to be very important for us to use in this conversation. So some of those packages are Pandas, Matplotlib, scikit-learn, lots of them. So if you want to install them, you could control backtick. If you're using a Mac, command backtick, and they could run pip install. And of course, it's definitely also pip3. You could say pip3 install, or they could say pip install. Then Pandas, NumPy, Matplotlib, and all of that. Okay. So I'm not going to run that because I already have all of these dependencies installed. the packages and modules and all of that is installed. So first we're going to start by importing NumPy as NP, then we're going to import Pandas as PD. Of course, we are going to import matplotlib.pyplot as PLT. Then I'm going to import joblib. So I'm going to talk about what we use some of these databases to do. And then from sklen.model selection, I'm going to import train test split. I'm going to import grid search CV. I'm going to import the cross validate and maybe the cross val score if we want to know what we're going to do. Cross val score, and from sklen.preprocessing, we're going to import one hot encoder and the standard scaler. Now, also another package you're going to import from sklen pipeline. So we're going to import the pipeline, and also from sklen linear model, we're going to import logistic regression. So we're going to be using logistic regression for this particular video. And I think those are actually what we might need now. But if there's any big package that we forgot to import, of course, we'll definitely come back to import that. But then we'll have to check our metrics, okay? Well, this is basically what we're going to be using to read our model. So we're going to import across, we're going to import the accuracy score, precision score. We're going to import the recall. We're going to also import the F1 score. We're going to import the confusion matrix classification reports and RC, EUC, RC curve. So this is actually what we're going to be importing, and I'm going to run that. And of course, that works. Now, what we're going to be doing, because if you're watching this video at the very end of this conversation, I'm definitely going to be leaving all of this code on my Git repository. So it means that you will definitely find this code on my Git repository. And so what that implies now is that we're going to save this in a class. We're going to create a blueprint, and we're going to call that blueprint Anaemia model, okay? And we're going to create def of underscore init, and then we're going to say self file path, okay? Pass. Now let me talk about what these packages are, and then I'm going to get the data sets that we need. Now, first of all, for NumPy, we're going to be using this for numerical computing, okay? And then if there's any kind of mathematical operation that we want to perform in this particular lesson, of course, the NumPy is going to be helpful for that. And we'll also perform computing, could say mathematical computing on our data frame, okay? And now the next thing we're going to do now is we're going to talk about what we use the pandas for. So we use the pandas for our data frame manipulation. So I think that one is just going to be very easy for you guys to understand. So of course we use it to create our data frame. Of course, yeah, anything you want to perform on data frame, Pandas runs on top of NumPy, which is a kind of C library. They were written in C, some C++. And for matplotlib, we use this is used for visualization. So I'm going to say for visualization, I'm going to use this, that's for visualization and graphical representations, okay? So this is used to save our model. And now, each of these now, this is just basically what we use for splitting, for handling hyperparameter tuning, and then For cross-validation, we use it for splitting to check how our model, our data performs on several parts. And then that's something for cross-file score, but that's just for one metrics, okay? That's if we're working on one metrics. So for one hot encoder, basically, we use our one hot encoder to just for pre-processing. Okay, we use it to pre-process data, and if there are some kind of values that are in categorical scale, we probably want to change it to numerical, we could use one hot encoder to encode them. And then for standard scalar, basically, we want to use it to normalize for normalizing variables. Okay, now for pipeline, this is used to create. So I'm not really going to kind of give so much theoretical view, but you could read up the documentation. You could check out the API references. This is to create pipelines for data reprocessing, for data processing. I'm going to say data processing, and this is the model or the algorithm. I'm going to say kind of the algorithm where the data sets will be trained, okay? And all of these here are the metrics and yardsticks for classification based, so I'm going to say for classification based machine learning to check how well our model is performing. So that's actually that. So this is just kind of some slight comments that are actually important for anybody who is probably working with this and you want to kind of get some insight on that, on what some of this stuff looks like. So this is the data set we're going to be using. I could just show you what that means. Looks like an Excel sheet. And we could just kind of open that, let it load for some time. And of course, I'm going to drag this in here while I'm waiting for that to load. So this is what our data set looks like. Something inside of the data set might look messy, but we don't really care at this moment. Probably when we're done with it, of course, we'll know what to do. And then now I could drag this in here. And you see I have my data set. So you have to add this and keep it, close to your, that's close to the file that you're working on. Now, so the next thing I'm going to do now is I'm going to go back here and, of course, we have defined this class. Remember, we are using an object-oriented programming approach, and we have defined the blueprint of this class. And what I'm going to do now is I'm going to say self.phi_part is going to be equals to phi part. And I think that is just that. I probably could say self.df is going to be pd.read Excel. Okay, this seems to be an Excel sheet. Could we pass in any parameter here? Maybe something like sheet size. So that could still make some sense, but I think we could do without that. And of course, that should be at the first line of the sheet. We're still going to confirm that. So this is going to be pd.readself.phi_part, and we're going to have sheet name at 0. All right, so we just want to get the first sheet name. So if you wanted to pass here, maybe sheet name, right? And maybe there's actually a specific name. I'm just going to show you what I'm trying to talk about. So maybe, for example, pass sheet name here, and then probably this self.sheet name is equals to sheet name. So what this is going to be here, that is going to be self.sheet name is equals to, of course, so this is going to be self.sheet name. And then that means we're going to now have to pass in what the name of that sheet name is going to be. Probably each time we call this method, and maybe if we do something like, for example, I'm going to show you what I'm talking about. So if we do, maybe let's call this anemia, it's equals to anemia model, and then we'll pass in the phi part, Probably we could say anemia, we could say. And then we pass in sheets. Sheet name is equal to maybe 0. Of course, that should work. Yes, that should work. So what this means now is that we have now assigned what the sheet name is. Because normally, if you have maybe df is equals to files is equals to read pd dot read it's an Excel file, and you have here maybe the name. You could do something like print files dot sheets files print files. Now, what this is going to do now, we will call this So I'm just going to show us something. What I'm trying to show you right now is how you can actually understand the file sheet names. Now, what we do usually is that, for you to have an Excel sheet, right? There are sheet names. Now you can see the sheet names here, right? So, but another way you could use to name in the sheet names, you could see zero indentation as the first one, because Python starts counting from 0, and then this is the first sheet. Then let's say we add another sheet here, sheet 2, the sheet 1, we'll have add another sheet here, sheet 2, and all of that. I just hope that kind of makes some sense. So, but here once we say 0, of course, but if we want to put the name specifically, of course, we could do that. So, but then I could decide to use this here. I could say comment to say sheet name is this. That's still going to work. It's still going to work very well. So, of course, that means I have not instantiated my this. So if I now say, if I want to print, if I say anemia dot df, it's going to give me this, right? So it's going to give me that, those sheets, that's the data frame, basically from there. I could just delete this. I added that just to kind of show you some stuff. And of course, I might want us to have something like this here. Maybe see df is equals to bd.read, read Excel, and then we'll have Anaemia this. Okay, so this is not in classes, but probably might want to use this to view 1 or 2 information from our data set. Of course, I'm going to be making some explanations from that. That's particularly for those people who are not really familiar with object-oriented program. So I think that is that. This is data frame here. We could decide to define other, empty in self.x is equals to x, and then we could say maybe self.y is equals to y. Of course, we could decide to define other, variables that we want to be at, that want to use any time. But of course, we can create those in our, maybe we can create them when we run several methods. And of that, of course, that's definitely going to work. Okay, so this is working very perfectly. And I think the next thing we're going to do maybe is to create another class. And we're going to call this class visualize our data frame. And we're going to pass in self, and it's going to take in, we're going to say self.df. So I'm going to say, okay, print head of data frame, and about to display the head of the data frame. But to display that, so we could actually say self.df.head. Probably I could just assign 10. Why can't we just print that? We could just print self.df.head, and then I'm going to print. I'm going to also print self.df.info. I'm going to print self.df. describe, and I'm going to print data frame, displayed and visualized successfully. Okay, yeah, I could just maybe mark something inside of there. That makes a lot of sense. So we're going to create another class, another method, sorry. Now, after we are done visualizing our data frame, now the next thing you might want to do, because this is basically machine learning, and the first thing you might want to do whenever you get any data set is to visualize your data set, understand what your data means and what your data is all about. And then after that, we might now want to just perform some kind of maybe cleaning. So what we can say, after we visualize, we could say maybe clean data. We're going to take itself, and just to be sure, maybe no, we could say check duplicates, and we say pass. After that, the next thing we're going to do is we're going to check, after we're going to perform clean data frame. We're going to take a self. So we just I just want to list out all of the methods that we're going to run. Okay. Then after you're done cleaning the data frame, because then you check the duplicates, and then maybe like check missing values. I think we could say maybe define was check missing values. That's gonna take itself. For now, we're gonna pass. And so after we're done checking the data frame, cleaning the data frame, we're gonna now create target. It's gonna take itself, and I'm gonna pass. And after we've created a target, we're gonna actually create a preprocessing. Then we're gonna perform our feature engineering. Self, and I'm gonna pass. Then after that, we're gonna perform, I'm just gonna call this one perform preprocess. It's gonna take self, and I think before that, we more want def split or detail self. For now, we're gonna pass. We're gonna pass. And because after we've splitted it, that is when we can now even perform some pre-processing, understand our X codes, numerical and all of that. And then we're gonna train, because pre-process here, we could maybe train our model. I'm gonna take self, and I'm gonna pass. Therefore, we're gonna evaluate our model. It's gonna take a self. For example, I'm gonna pass. And then also what we're gonna do after that, we're gonna cross validation. We're gonna take a self, pass. And what else can I want to do after we're done evaluating? Because we do cross validation. Then I'm going to perform tuning. We're going to tune our model, tune model. Okay. And I'm going to pass. After performing tuning, then we might want to now tune our metrics. Tune metrics, because after we've done tuning, we now want to now get the metrics of the tuned models. That's, of course, how the models has performed. That's all. I'm going to say evaluate, tune, evaluate. Okay. It's going to take itself as usual. Then tune visualization, going to take itself. It's going to pass, and then I'm going to perform some prediction. Self, pass. Then I'm going to we could No, before then we could just def save model, save our best model. I'm gonna pass and def we're gonna load our model self pass. And then we'll perform some prediction, and that's it. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'll have 10, 11, 12, 13, 14, 15, 16, 17. Okay, and we could def visualize targets. So we could do that. So that's 18, and we could do what we call check, maybe at last check maybe some kind of more visualization self class. So we have about 20 methods that are running on this, right? So we have 1, 2, 3, 4, 5, 6, 7. Then we have 8, 9, 10, 11, 12, 13, 14. Then we have 15, 16, 17, 18, 19, 20. So we have 20 models, 20 methods for this particular class. Remember, what object-oriented programming does is that it makes it easier for your code to be well concise. You can always reuse your code, and it could definitely perform a lot of things, with your blueprints or the class that you instantiate. And those are actually what we're going to be doing right now. Okay, so we're going to be building everything from scratch. Don't worry, even if this is your first time, of course, you just need to bring out your computer and start coding. So basically, we have this done. To check our missing values, I could just show you something, because if we come here and we do df, remember, just kind of run this. And of course, you're going to see this. There are some other methods that we might want to add. Cleaning our data frame. Okay, inside of here, we can change our column names and perform everything at once there. So what I wanted to show you now is that if we do df of maybe df dots, maybe to pregnant, I'm just going to say, for example, I say dot unique. Now you're going to see something that inside of these values here, this is a float variable, right? You're going to see that we have asterisks here, we have asterisks here, and if I try to, because I'm performing a quick visualization, and I do something like maybe this dot unique, okay, now you're also going to see that I have some, okay, probably count some spaces, and I could just do another one, just so that we understand that instead of our data frame, right? Okay, if I say df.head and I put it at 20, now what will happen now? If you're looking at this data frame now, you find that we have an asterisk here. So this is not a number. And if I kind of change this to df.tail, let's look at it from the bottom. I could just come to the bottom. That's from the bottom here. You could find out that we have some still asterisks here. And yeah, there are actually some irrelevant, entry, so irrelevant parameters that maybe authors might have entered and all of that. So, and we don't really want all of this, okay? So it means in our data cleaning, we must make sure we account for all of this, right? I could still show you that there are some parts of these data sets where we have some brackets. Let me increase this to 30, so that we could see. And yeah, I'm just going to show you something right now. And if you look at this data frame, you see we have brackets here, and it could see some brackets here. And this is not important. This is not nice for our data flow. Okay. Just going to say dot 1.2. And okay, that's based on here. We could also see some 61.2. You see, it's coming out here as a negative value. As a negative value. That's why we're having these negative values here. So if we do for the last one now, maybe so, for example, I do something like maybe df of maybe men and all of that, and I say dot unique, you're gonna see that, okay, that is still, we still actually have some of those stuffs here. So what it means is that we might have to kind of remove that, okay? So what we're going to do now first here is we're going to print about to remove, I'm about to remove missing, no, about to check missing values in the data set. I could just type that, and then I'm going to say, first of all, I could say self dot, I could say df is equals to self dot df. So I'm going to reassign it. I'm going to say df dot is now dot sum. I'm going to print this. Then I'm going to also print df dot is now dot sum. So this is checks none values, and this is going to check if there are some missing values in the data set, okay? And of course, that's what it's going to do. And I'm going to kind of print. Of course, I'm going to print no values checked successfully. And what I'm going to do here is I'm going to take out this pass, and I'm going to say self dot df is equals to self dot df dot drop, okay, as the quality sign dot okay. Before we drop that, we could just say self dot df dot sum. So I'm going to show you how this works. I'm not going to pick the self. I could just come down here. I'm going to say this. Okay, sorry. And it's going to return 0. So it means that there is no duplicate. If you take out this sum here, it's just going to return an array of all of that. But it's better we just say dot sum. And this is also different from df dot duplicate. Okay, there is no method that does duplicate all of that. So this is just kind of to confirm for you, because each time I run this, definitely I'm going to show you what that means outside of the class, so I can be able to comprehend it. All right, so we're going to print, I'm going to print about to check the duplicates in the data frame. Okay, all right. Yeah, so that's actually that for that class. And so we could just say, okay, we'll print here. I'll go print duplicate checked successfully. All right. So here now we're going to talk about cleaning our data frame. So with the self.df, I could say df is equals to self.df. And probably I could print about to clean our data frame. Okay, and I'm going to say self-df is equal to self.df, and first of all, I'm going to say df dot drop duplicates. Okay, actually, I think I might just assign df is equals to df dot drop duplicate, and what else do we want to clean? So I'm going to say this is to remove the duplicate from the data set. And then we could just say df dot. Now, I don't know if this is going to be confusing to some people. What this definitely mean here is that I just kind of reassigned this. If I remove this line, then this is still going to be self.df. I think I'm just going to take out that so that it doesn't confuse some people. Self.df, I'm going to call this here self.data. I'm going to take out this line. Okay, so but it's still basically the same thing. The reason why I'm putting that line there is that sometimes maybe when you're already programming outside of objects or you're not using object-oriented programming, you might just want to wrap everything inside. You're just familiar with df, and all of that, okay? So what we can do now is we could say self.df dot is equals to self.df dot replace, and of course, like I said, we have a bracket there. We're gonna replace it with this, and I'm gonna say regex is equals to false. Self.df is equals to self.df dot replace, and I just got to cover this way, and then regex equals to false. Now, could also self.df is equals to self.df dot replace. We have a storage there, and then empty. We see regex equals to false. Now, the next thing I could do now, I could say self.df is equals to self.df dot replace. Now I'm going to turn that to mp.nan. mp.nan regex equals to false. So what this does now is going to convert some of those params, that are actually inside it into a non-value. And I think I could still drop those non-values. I could say, okay, drop the non-values. I think we could have another method, encode category. Okay, so that's going to take in self. We're going to pass as usual. So to drop the non-values here, well, let's call this remove errors, and then just to make it easy, about to remove errors from our data frame, and I could just say errors remove successfully from the data frame. Okay, right? And excuse me. So we could just create another class there, and then we're gonna call this drop none. Drop none values is gonna take itself. I'm gonna send uh about to drop none values. I'm gonna say self.df is gonna be equal to self.df dot fill now. Now, so fill now with now. So what we can do here now, we could say fill uh self.df, and now we can say uh include equal to forward fill dot fill now include. Now I'm going to show you what this kind of illustrates now. And first of all, before we could actually demonstrate what this means, in such a way that we could see it from the code before wrapped into the object. It's very important for us to have this code running, this particular method here, and I could just highlight that. Obviously, I think there is no duplicate inside of this data set. And we could just run this. Just so we illustrate something, okay? Now, let me show you what happened. Okay, so df is not defined. We're going to run all again. And that should be sorted out. Okay, just gonna give it a second. I want to show you what this means. All right, fine. Okay, so that's actually duplicated behavior. And is it include? Okay, that's supposed to be include. That's supposed to be okay. All right. So now let me show you what this means now. It doesn't come out with a duplicated behavior. But what forward fill now means that you're trying to fill each of those columns. Now, let me give you an example. Take, for example, we have this data set here, and what forward fill is going to do is that while it is coming down, this place is going to be filled with 552.2. Now, another strategy, we could use df.min, right? We could use the data frames mean But it can only happen if we have all the columns here as numerical columns, but we have some categorical columns there, so that's not going to work. But the forward fill and backward fill is if we have an empty cell here, backward fill is going to fill it with the next preceding cell. But forward fill means that 31.1 here is going to be 31.1, here is going to be 34.8, 34.8, 34.8, and so forth and so on. All right. All right, so that is what it's all about. Okay, so I'm going to jump straight in back on code, and that's just what it is. I just wanted to illustrate that. And of course, we could trash out this. I don't know, I just made a mistake with that. I just kind of wanted to illustrate some stuff. So encode category here, drop non-value. We could still so after we've dropped non-values, are using forward and backward filling. Okay, there are actually other approaches. I could just run another method here. I could say def self.def dot drop columns. Now I'm gonna say self.df. Okay, probably okay. We can wrap that up inside the next function. So probably could just fill all non-values replaced successfully. Okay, of course, that's going to work perfectly. And so here for us to encode, so we're going to actually print about to encode some cats, some categories, and we could just say self.df is equals to self.df dot drop columns is equals to I think I want to drop states. Or we could just add a method. We say rename columns. Okay, we could say rename column names columns. We take self and print about to. I'm just gonna going to print some pass here so that there won't be any issue. About to rename the columns properly. And I'm going to dissolve the df dot columns is equals to self dot I'm going to say self dot df is equals to self dot df dot rename. Okay, so columns is going to be equal to. Now let me show you something right now. If you come here and you do df dot columns, probably dot to list. It's going to give you all of this in columns, so I'm just going to copy that. And I'm just going to paste that here. And what I have here is states. Okay, and this is going to be area. Now, this is going to be children. So this is going to be children. I feel like that's just the only children we have there. 659. And probably might plot some kind of scattered plot. And this is no. So I'm just going to say some kind of non. Uh, okay. And this is a very small data set of pregnant men anemic. So so what we're going to do for the next one. Hey, sorry. You don't touch anything here. If you touch it, that thing is not going to name. So this is 15 to 19. You don't have to touch anything here because this is a column you're renaming. So you don't touch anything there. And this is going to be men. Men. And I think I can just copy this. Of course, we have what is time 19. I think that's the whole thing works really well. And just to kind of confirm, we could just run this outside of this class and just kind of put something like this and jab that, move the self, close it, close the cover, and run df dot columns. Just show you guys can see what I'm doing. And you can see that I've normalized everything, okay? So return back to our class, and it's not definitely going to return anything. This is just do this, and we're going to print uh, names successfully renamed properly. And now, so we're going to try to kind of encode and drop category. Let me call it encode and drop category. So start by and drop some categories. So I think states, we don't really need that. And that's not really very important for us in the data frame because unless we could use something like maybe high dimensionality to encode that. But I think, yeah, we could drop that or we could use it, but regardless, I don't really want to work with that. So what we are going to do now is gf.column drop state. And of course, it should drop that. And then we're going to say self.df of what should now be area is going to be now equals to self.df of area.map. So kind of, so wrap it in a dictionary. Now we'll check what that gives you. So if you do df dot area and then let me see dot unique, it's going to give you these three parameters. So I have urban, rural, and total. And of course, we could work with that. And what I'm going to do now is I'm going to basically come here and I'm going to put that inside of my map. And this is going to be 0. This is going to be 1. And this is going to be 2. I think that should work. So I'm just going to, sorry, you need to obey the indent. I'm going to print categories dropped and encoded successfully. So now, so guys, so right now that we have our target, we can, sorry, right now that we have all of this, we could decide to create our target. And what's our target? Our target now is we could say, okay, I want to print about to create our target variable. So our target is basically what we're going to be using to make some targets. And how if I'm going to do that, I could start to create a function, a nested function here, and apply some logic. So for example, I could say estimate. Now, right now, if you look at this data frame, we have women who are anemia, we have children, we have men. So I could decide to say that if it is greater than so and so range, and then probably less than so and so range in children, then that is 1, which is risk of anemia, and then if it's kind of the other value is definitely going to give you less. So I could say estimate anemia, maybe create a function, and that function should take in women, and it should take in child, and probably maybe men. And of course, that's what this nested function is going to take in. And then inside of this function, I'm going to say return 1 if probably women. Now, I think this is just a nested function. If women is greater than maybe 45, and let me just kind of wrap this inside the bracket and see. And child, or could say greater than or equal to 45. I'll show you what I mean by that in a jiffy. And child probably is less than maybe 56, and men is maybe greater than 44 else 0. So let me show you what I mean by that, okay? And before I show you that, let's kind of end this. And of course, this is a argument, so we can now say print. Okay, no, we're not printing yet. We can say self.df of maybe anemia status. Okay, that's going to be equal to self.df dot apply. It's going to take in a lambda function of maybe row, And we could actually call this function estimate anemia and pass that row to be who are these women? Are they pregnant or non-pregnant? Probably you could say maybe women who are not pregnant. Just kind of building on a logic for us to get that. So let me show you what I'm talking about right now. So if you look at this now, this is for children. We have values at 65. So many values here are actually high. And you could do something like, I think since we normalize this, you could do something of, let's just have df here again, and could do something like df dot children with anemia dot maybe dot info. Let's see. Let's have some kind of describe. So we have a top 45, frequency 2, unique. So meaning that we still have the reason why this is doing this way is because we still have some kind of values inside this, and so there the data types. No, that's not callable. And you're gonna say everything is still an object. Wow. Hmm. So we might want to convert to numeric so that we can be on the safer side. Mm, okay, we could just comment this out, run all, just to be sure. Okay, those are still as an object, despite dropping, did we drop none? Hmm. Just gonna show you guys some things, and of course, we could just drop none and run all. Okay. So after we've dropped none and we've renamed, what we can do now is encode on drop. Okay, we've still done this, and could convert to none self, and we're gonna say self dot calls is equals to self dot df dot self dot df dot uh, select include a quarter. float 64, and then we'll have int 64 dot columns. So I'm going to say 4. I'm going to say for call in self dot calls. Then I'm going to say df of call is equals to pd dot to numeric or df of call. Then we have errors equals to course. So I'm just gonna print ensuring everything is in numeric. But then, so let's check and see what we've done. I'm just gonna okay. Just need to be sure that so we're kind of starting our kernel and then okay, still an object. Okay, and all right, so let's continue. So what we're going to do now is because basically we want um to get to choose. Okay, are we interested in women or maybe men with anemia 50 to 70? So anything, it could be your logic, okay? So I am not really specific, limiting it to any particular one. So it could be pregnant women as well. Yeah, that could also be That could also form some part of my logic. And of course, trust me, that's totally fine. So I think I could use children if they are greater than, if they are greater than or less than 50. I think less than 50 is gonna work. Yeah. And then so that's children. What's the name? Name becomes so what's the name going to be? That's going to be children age anemic. And I'm just going to kind of copy this. And pregnant women. And or could just add the idea of dot string dot replace dot string dot replace dot string dot replace string dot replace. So let's see what happens. Float, let's just say, and let's ask type, float. Let's ask type float. Okay, oh no, that's not gonna work. What's happening? And trying to. Forward. Oh, we made a mistake. We made a mistake in our spelling. I guess we made a mistake there. We added an extra F. See how one mistake can change your object. So it means that this thing was not supposed to be object. This stuff here, I already spotted this error here. The data type here is supposed to have changed to float. Supposed to have changed to float, but we added an extra F in our when we wanted to fill. So you need to be very careful, and that is why this thing is bring throwing up that error. It's not throwing up an error actually, but that's why we are already suspecting why. So we're gonna run all. Of course, that is going to change now to float. It should change to float now. Of course, run that. I think there's an error throwing up. So we'll have to sort that out. Let's sort it out. I'm just gonna comment this out. So kind of restart our kernel to make sure everything works perfectly well and how we love it. And okay, it's still here. It's still showing here. What is happening? Like, and we're gonna run all. That just has to give us a float. This has to be a float. And this has to be dropped. Okay, something is still wrong somewhere. Um, still means that oh, we need to restart. And then what we can do is, I think I'm gonna delete this and of course, no. I'm gonna add method equals to forward fill, and that's what we didn't add. Oh, sorry. Method is equals to forward fill, and oh, that should finally work now. I'm gonna run all again. Of course, that works perfect. So, so we have that now as float, and that was just a mistake. I don't know how I was just kind of dreaming. Method is equal to this, and method is equals to that. So all non-values has been replaced. I don't think we should have this method again. This particular method, I'm going to take it out. Here where I'm trying to force it into, uh, you know, force them into numerical values. I think I could just comment that method out. And then so basically what I was trying to explain here is how you can create your how you can create your data and Of course, what you can do right now is anemia status apply. So the role that we're interested in, kind of go down again. And yeah, already, we've encoded area and dropped state, so it's not going to be showing there again. So, but what we're interested in now is in children and men 15 to 20. So I'm just going to kind of go up and okay, so we're trying to create our risk. And I'm just going to create a multi-line. And inside of this, I'm going to paste this. And basically, what this is going to have here is maybe it's going to have children, right? So I'm going to wrap it inside here. And that is, and then I have women. Well, it doesn't matter the order. There's no issues with that. And excuse me. Well, I have row of, now that's, second one now is women. So it's going to be non-pregnant anemic. And then the third one, row of, that's going to be men or equal to, you can say less than or equal to, okay? And add this one. So that is definitely going to be that. So we could just check out this. Although this is wrapped inside of a function, so we could just check this out outside of our class just to see, explain what we are doing so that you guys can understand. So this is a class, right? And this is a class. And then inside of this class, we have this. And I think that is there any self inside here. I'll take out this. I'm going to say df. Let's see. Oh, it seems like df dot anemia status dot value counts. Let me see. Oh, it seems everything is zero. Our rules are very, very tight. Well, let's drop for men and drop it. The rules are very tight. And then run that again. Okay, sorry, we made a mistake. We didn't remove I didn't remove it from here, man. So we should run it. I think this is slightly better, but is there any way we can manipulate this further so that we can get, maybe we could just less than or increase it to 60, 66 and see. I think it's better. Maybe let's increase it to 55. No, let's take it down to 45 again. Let's take it down to 40. I think this is fine. We can go with this. So anytime non-pregnant women who are anemic, they are rated less than 40, and then children, no, the children greater than 40, and then children are rated, who are anemic are rated less than 66, then that means there is risk of anemia. Okay, so that is just that. I could just copy this, and so basically this is just our playground outside the class, right? While we are building our class. What did I even just? I just did children at 66, and I kept women at 44. And I took out men. Of course, took out men here. And of course, so that is it. And so could just print here. We could just print our risk target created successfully. All right, so that is that. And I think I'm just going to kind of delete it. Now, so we can actually perform some visualization on our data, on our target. What we can do here is we could say print about to perform some visualization. And I'm going to say plot the figure, and then I'm going to pass in fig. I'm going to pass in a fig size of 6 and 7. And once the plot dot bar. Now, what we'll do first is that, now what I'm going to say now is, I'm going to say anemia rate is equals to self dot dot okay, and index anemia. Then we can have color as maybe red, alpha at 0.4. So I'm going to call this anemia versus no anemia. Let's just call it that way. I'm going to say plot dot x label. That's going to be anemia status 0 is equals to no anemia. 1 is equals to yes anemia. Okay, this is just how you can understand plot. Say plot dot so this is going to be plot dot y label, and we'll have we'll say this is going to be the we'll say values. Is that the right word? Or we could say the distribution, or we could say something like the data. No, that's not the right word. Or we could say the scores, or maybe thinking about a better word to use now for the numbers there. Let's use distribution. Distribution of the values. Oh, it's something like rates of the rates. So we're going to say plot dot y lim. X lim should be 0 and 1. Plot dot plot, no, say plot dot I could check the x ticks, right? So what's the what this should be now? Say plot dot read. I'll say true. And I'm gonna say I'll say alpha plus 0.3. This should be 0.7, and let show as a plot of tight layout. Plot dot show. So could just print plot successfully displayed. Okay, so we could just perform some correlation between the children and the non-pregnant, and the pregnant women. So could you say plot dot print about to show the scattered plots for the relationship between the children and the pregnant women. So when it's a plot dot figure, and gonna have fixed size of 5 and 6. Plot dot scatter, and then I'm gonna pass in self.df of I'm just gonna go down right now so you could check it. Children with anemic. I could just copy this, right? So let's I think we're gonna also do another plugin before uh pregnant women versus non-pregnant women. I might show an outlier, and what plots can we display here? Let me just So I'm just gonna copy this and put that in. So .df of, and when we're doing this with pregnant women, color is equals to blue, edge color is equals to maybe black, and alpha is equals to 0.6. Plot of title, we're going to say relationship between the children with anemia versus pregnant with anemia. Okay. Then we're going to plot the X label is going to be the children with anemia. Plot dot Y label is going to be pregnant women with anemia. Plot dot grade is going to be true, and alpha is going to be equals to 0.3, and plots height layout, plot show. So I'm going to call this plot, I'm going to print split relationship between children and the pregnant. Okay, so I'm going to actually print next one, and I'm going to say dot but maybe we could just create another method, and this is scatter visualize. I'm gonna call this def. I can say box plot visualize self, and you could say print about to inspect outliers among children with anemia. And then we could just say plot a figure, and then we could say plot dot box plot, and now passing self dot df of children with anemia. I think that's actually the product. Plot dot title, I'm gonna say children with outlier visualization for children with anemia, and then once a plot dot X label, as a children with anemia, and then plot up with the print, plot the show, shows this. And true, false. It's like to call that And again, I could just say def, probably we could do men versus women. Self, of course, takes a self, and then I'm going to say print successfully displayed the box plots for children with anemia. So could just say print power 7 and plot dot scatter. And then we have self. So we could just scroll up, and then we're gonna take this. And then we're gonna pick no women. It's better you copy it, or it's better you copy it so that you minimize chances of running into a bug. So, and oh, sorry, I wasn't done writing that shit. And so the next thing I'm gonna do now, I'm gonna say plot dot show. No, not plot dot show. How could that be? So plot dot title. I'm gonna say relationship between women with anemia and adult men with anemia. There's a non-pregnant with anemia. So X label is going to be non plot is going to be adult plot dot grid is going to be true, and then alpha is going to be equals to 0.4 plot dot show. Okay, guys, so this is just basically, we've really done a lot, and honestly, in all honesty, it's just kind of trying to know how this is done, so we could just print successfully printed the relationship between men. So I think you could just add the last line here, plot dot tight layout. So that's that. We'll move to the next part. I'm going to leave the pass here. So I'm going to say, what do I need to talk about right now? So I'm going to print about to create our X and Y features. So I could just drop this as this. I'm going to say our self.x is going to be self.df self.df dot drop. So what's it going to drop? It's going to drop columns of anemia status. Okay, and self.y is equals to self.df of anemia status. Then, of course, if that is the case, then what we're going to do now is we're going to print successfully created the x and y. So that's the thing. And the next thing, we're going to split our data. Of course, that is not going to be an issue. We could do print about to split our data, and we could just do self x train self dot x test self dot y train self dot y test is equals to train test split of self dot x self dot y. And if the reason why we use self here is so you can actually use it in other methods. But if you do x here and you try to do x here, it's different because this one now it's already a different method. All right, so it's quite important for you to understand that. You can actually look up my video on object-oriented programming. We're gonna say the size of 0.3, and then we can have I think I could just do 0.2, and we could have a random state of maybe 90, and maybe stratify equals to self dot y. So we are good, and so we could just print our data has been successfully splitted. I think the majority of the whole programming and all of that is in that data cleaning. That is the part where, like, that's the part where every headache is. Do you understand? Understanding how to use different methods, how to check it from this side, how to fill it. That's the part that you need to practice and practice and practice and practice and practice. Every other part from here down is easier to assimilate and understand because you're not really performing so much cleaning or pre-processing, but it's easier to change things and all that. But if you're coming with an unclean data, is a problem already. Do you understand? And it's going to be very erroneous on real world data. So for pre-processing, what are we going to classify that to be? We can pass some of our terms into column transformers. I could call this column transformation, but what I'm going to say now is self dot calls. I think basically everything here is in numerical columns, and I could just say is equal to self.df dot select data types of include for me equal to float 64 and int 60. Oh, sorry, int 64. Okay, dot columns And that is just, okay, that dot is not there. Dot column. So what this means now is that I can now perform my pre-processing. I could my column transformation. So I could do self dot preprocessor is going to be equal to um, I just hope this doesn't fit in Y because that's an int. Okay, this will self dot x. Okay. So you don't fit in your self dot y because if you do df, it's going to fit in everything. So we do self dot x dot select data types here. So basically, these are actually the columns. You understand all of them. If we had like uh categorical columns there, we could just say something like self dot cat calls, maybe cat calls, and we're going to do self dot x dot select data types. And we could see include equals to, no, that's a dictionary object. Okay. And we could say that's columns. Of course, that should still work. But we are not interested in this because we don't have that. So I'm just going to uncomment that out. But this just has to be X, please. Don't make it DF. Because if you make it DF, then your target is going to be included here, of course. And that's not what you want to do. So I'm going to say here, I'll save the preprocessor. I'm going to say column. Just to be sure we imported that library. Okay, we didn't, and we did not sorry, from sklearn.compose import column transformer. Okay, so we are good, and I'm going to go column transformers is going to be equal to. All right, so that's what we're doing, and right, so what we're going to do right now is we are going to actually like add this here, right? So transformers is equals to I'm gonna say prepros. Okay, no. Yeah, this is going to be num. Because we're trying to pass the transformer, so we're gonna say self.calls, and then we'll have our and this is going to be the standard scalar. No, this is going to be num because that's the name of it, and then we'll have our standard scalar, and then we'll have our self dot calls. Okay. Remember, this has to be in columns, even if it's one, or it has to be in the list rather. So automatically I'm going to that is that basically. And so for us to get our pipeline ready, I'm going to just print about to pre-process through a column transform. Yeah, so now the next thing we're going to do now is we're going to train our model, and we're going to pass it through a pipeline. So I'm going to print about to pass our model through a pipeline for fitting. Okay. So what we're going to do right now is so of course I'm going to say print pipeline. That's going to be self.pipeline is going to be equal to pipeline, and then we have steps. That's the step now for this pipeline. Is going to be this. And of course, we'll pass on preprocessing, and then self.pre self.preprocessor. And of course, we're going to have our model, and this is going to be the logistic regression model. Okay, maybe we could set our max eta to maybe 200. That's the max iteration. So self.pipeline is going to be a pipeline.fit. Gonna say self.xtrain, self.ytrain, and is going to return self.pipe. All right. And then the next thing we're going to do now is we're going to perform some kind of evaluation here with our pipeline. And what we can do now is we could just say, is there any need of printing anything here? No need. We could just say, we just print about to perform some evaluation metrics. And I'm going to say, now there are several evaluation metrics that we can perform. We could perform accuracy, precision, F1 score recall, and all of that, because basically what we're doing here is binary classification. So it's not regression. If it was regression, we could just find the mean squared error and then perform our prediction, but not in this case. So what I'm going to do now is for the first, I'm just going to kind of use a comment. I'm going to say the accuracy. We could say self dot prime question, we say self dot whatever term I want to use in the next part. So because I print accuracy of the model self dot, and that's going to be accuracy score, then self dot y test, and self dot maybe y pred. But before we perform that, before we get that's y pred, we need to say our self dot y pred is going to be equal to self dot pipeline dot predict self dot x test. So this is going to return an array of zeros and one, and self dot y probable. We're going to put self dot pipeline dot predict probable self dot x test. Okay. So this is just going to return some kind of so it's going to some float values, that kind of shows the probability of which event that's happens. Because if you have to put this here, because if you don't put this, it's going to return some kind of a two-dimensional array, and you cannot really use it to uh kind of look for ROC, because that's definitely what you might want to use to check the differences between the false positive against the true positive that's on that plane. That's what this is going to be. So for precision, and then we could check for the F1 score. So we could check for the recall score. Then the next one I want to look for is to estimate the ROC AUC. So I'm going to kind of print. I'm going to print the ROC AUC is going to be equal to self dot y test. Oh, sorry, I don't know why I mistakenly did that wrong here. Y test and self dot y. Then the next one is going to be, I think that's just that. Unless we want to print the confusion matrix and the classification report, then that's where we might confusion report and confusion report now, and then the confusion matrix and the classification report. Okay. So this is going to be for the confusion. And it's going to be for the classification report. And I'm just going to kind of print that. I could just add a new line here. I think those actually, that could just put print successfully. Successfully evaluated all the classification based metrics, okay? So, yeah, could just bring this somehow together. And so now the next thing is cross-validation. I'm going to print about to perform some cross-validation. And so we could just say self.cv. I just want to be sure we imported the stratified key fold. If we didn't, of course, we're definitely going to import that, and we could get that from here. And then grid search series imported, and so what we are going to do now is self.cv is equals to stratified key fold. But I don't think I ran that, just to be sure it did. And I'm gonna have end split at 5, and then shuffle as true, and then random state at 6, and then scoring. So we could just call this self.scoring. As per eventually, if we use this method in another part, I could this is equals to this over accuracy, and accuracy, and then of course we have our precision and our precision, and we have recall, F1, and we have ROC AUC plus ROC AUC. So what we might do now, so we can see our CV result is going to be equals to our cross-validate. Now, the cross-val score, we use it for one single metric. I could just use it, we'll say solve.cv result, but we use this for like one metrics, right? Just kind of one metric. If you want to do only for accuracy or for precision, ROC, F1, recall, whichever one, and just one kind of metric. Of course, we can use the cross-val score. All right. I might not really be using that now, but that is just what it is. Scoring is the same, but you pick only one metric, one scoring metric. So for the cross-validate, we'll have to pass this method inside of this, and what this implies here is that we'll have to pass our self.pipeline, self.x, self.y, and then we'll pass our CV is equals to self.cv, scoring is equals to self.scoring, and it's going to return trend score as false. So to print that's to display our cross files validate scores as the cross validation scores. So I'm gonna kind of print. So I'm gonna see for our accuracy cross validation. That's I'm gonna call this the mean, because it's gonna return 5 scores. So we just want to pick the mean. I'm gonna say self.cv.result, and then we're gonna pass in test accuracy, because this is a dictionary. This is what it should be. And so could just run this. That's mean. And so, so this is what it is going to be. And so this is going to be the F1 cross-validation mean, self the result, and here is going to be test F1. This is going to be ROC AUC cross-validation, and going to be test ROC AUC, and this is going to be precision, and this is going to be recall. Just change that to recall. So it's going to just print successfully. Was So now guys, the next thing I'm going to perform now is our hyperparameter tuning. Now I'm going to show you something right now. I'm just going to show you something right now. Let's take, for example, we have the model, and that is equals to logistic regression. When we do model dot get params, it's going to display that's all the kind of all the components of this algorithm that we can tune. Now, basically, this same thing also applies if we do for, let's say, for example, the model is equals to, we will say from, for example, from sklen dot svm imports svc, and then we say model is equals to, for example, is equal to svc, and then we see model dot get params. Okay. Now these are these are what we call the parameters that we want to tune to get the best estimate from this model. Ordinarily, when you import your maybe your model from scikit-learn, the default values might are quite okay, but they might not really be what that is definitely going to be the best for the type of data sets that you have. So that's why we perform what we call hyperparameter tuning to tune this model, check out other parameters, and then see the best state that this model could be, or we could use it to perform some kind of prediction. That is just what hyperparameter tuning is all about. So what that means now is that when we come here to this particular tune part, uh, we are going to show you what you're going to do. And basically, we're going to start by saying maybe a hyper model is equals to, maybe I'm going to call the pipeline. And no, this it should be the B pipeline. Oh, am I right? Pipeline, and then have our steps. Of course, we're gonna have a model. This is going to be preprocessor, self.preprocess. Okay, and CLF classifier, and we have our logistic regression. So what this is going to be here now is that it could pass our maximum iteration here as 1,000, but I'm just going to leave it like this for now, or maybe I could just leave that for now. And then what I'm going to do now, I'm going to call this param grid. Param grid. I'm going to set it out. Now it's going to be inside of a dictionary. So this is our param grid now where we're going to put in all those parameters. And we have our CLF because this is it. Okay. And then underscore underscore. We have C. So we could see what is that times going to be. 1.0, 0.1, 10.10, 10.0, 100, 100, and now that is the first parameter. And the next one is, remember we're working with this. We could just go to maximum iteration, okay? I'm just going to copy that. And I'm going to do CLF underscore max eta. Okay, I think I might want to copy this so that I don't make any mistake. We do 200, we do 300, we do 500, we do 1,000, we do 500, 800, 1,000. The more parameters you have, the more time it's going to take. So let's not really. What's the next thing we're gonna check? We're gonna check Njobs solver. Let's go with solver. So we're gonna add the solver and CLF underscore solver and yeah, that's it. If you've got any other params, you could add them. Oh, but then you could actually look up the documentation. So how do you by that? You could just go online and search what are the params to enter into maybe logistic regression for max. That's a max eta. That's for solver during hyper parameter tuning. Okay, it's allowed. You can actually ask Google and all of that. Of course, it's going to show you. Okay, so you can enter this linear. You could actually enter this. It's recommended for small data sets. So we could come here, right? And yeah, could add that, and also we return back there, and we could add Saga. Okay, and as well as many. You understand? So we could go ahead, to add many verbals and all of that. All these ones, they don't really have any sense. So let's say we added max eta in that distance. Say, what of max eta? What of max eta? Let's see what it's going to return. Of course, it's still going to tell us that we can also add a maximum iteration of 10, 200, 500, 1,000, and all of that, which is basically what I've done, when we go up. When we go up here, you could see that I have actually done that. So I think that was actually that. CLF, what of for CLFC? Let's confirm. Let's still confirm and be sure. Say what of C? What of C? You see, it's gonna say we have 0.0010 and all of that in our param grid. Okay, so that is just to show you how it works. And you see, I added them literally here. If I could still just paste, what I actually got there, and that is still very fine and very welcome. So that is what we call hyperparameter tuning, where we kind of tune through the models, to get the best. So what we're going to do now, I'm going to call grid dots. I'm going to call grid is going to be equal to grid search CV, and then we're going to pass in our hyper model, just to be sure. And then we're going to pass in our param grid, and then we're going to pass in our CV is definitely going to be equals to self.cv, and scoring is going to be equals to accuracy, if at all we do need that, okay? But that's not an issue. Grid.fit self.xtest. I'm just going to pass self.xtrain self.ytrain self. So we're going to add this to it. We're going to say self. Okay, I'm going to use this outside of here. Self.grid, or do we need to? So we could say grid dot best estimator. Okay. And so that is just kind of to return the best estimator. I could just do print grid dot to get the best params. Well, that's the best parameters. We could print grid dot best params. Just to be sure this is correct. Probably we'll still check. We'll get back. And we might use our grid self.grid as a self.grid of it, self.grid of best estimator. And as we were saying, self.grid.best. So what we're going to do here now is we're going to say to have our best model. So we're going to say self.grid. We're going to say self.best model is equals to self.grid.best estimator. Okay, so that's our best model. So to tune, I'm gonna say our self.y tuned pred is going to be equal to our self.best model dot predict self.x test. And so the y tuned proper equals to self dot best model dot predict proper self dot x test, and then to display self dot to see the accuracy when also print. So first thing we could see here is our print about to perform our tuning evaluation. We see print successfully got our best estimator. So this is going to really help us identify where the bug is living. Gonna print about to perform hyperparameter tuning. Okay, and then we're gonna see here successfully performed hyperparameter tuning and got our best estimate. Return self.read.best estimator and okay, and okay, and for the accuracy is going to be accuracy of tuned parameter. Uh, that's going to be equals to accuracy score, and then you're going to pass self dot y test and self dot y tuned pred. So we're going to check how this is going to perform on other metrics like that we might be interested in, probably like precision, and we're going to just print that. I'm going to say precision and precision score. And then we're going to say for F1 score, because F1 is kind of the is kind of how we combine our recall and our precision. Okay, so for F1 score, we could just print that and say F1 score, and then we're going to say F1 score. And yeah, of course, I will go check out our recall. Recall. And is there anything we need to add? Probably our ROC. No, we could just check out our new classification report, new classification report. And I could check our ROC using. But here is going to be the self.y tuned prober, and gonna print successfully got all our tuned metrics. So we're going to perform some kind of tuned visualization, and then what we're going to see is FPR TPR underscore is going to be equal to ROC code, then passing our self.y test and self.tuned y proper. And this is visualization based on our tuned model. So it will print about to perform some visualization of ROC for tuned logistic model. And then we could just say plot dot figure. It's kind of a fig size of 6 and 8. And we're gonna have I think 6 and 5 works. Plot. So this is gonna be a line plot. And we're gonna have FBR. Okay, so could just FBR, TPR, label is gonna be with an F string to say ROC, AUC. It's gonna be a bottle. We'll pass the dictionary inside of it to our ROC, AUC score. That's going to take in our self.y test and self.y tuned proper to F. Okay, it's going to get to this mark places. Now I'm going to plot, and I'm going to have 0, 1, 0, 1. So just to give us a line plot, and then the line style for that is going to be this, and nothing really. We could just say color. Color might be equals to maybe red. It's fine. And let's say plot dot title. We're gonna call this the ROC curve for anemia prediction, right? For anemia prediction model. And let's plot dot X label, and then that's going to be the false positive rate. And the plot dot Y label is going to be the true positive rate. And the plot dot let's call out X lim. That's 0 and 1. Plot dot Y lim. 0 and 1. Plot dot tight layout. Of course, plots dot read true and alpha 0.5 occurs 0.4 plot dots show and could be plot dot legend uh, just print plot successfully displayed. Now, so we're going to save this model, and that's going to be very simple. We're going to say job lib. We're going to print about to save our model, probably our best model. So I'm going to say joblib.dump. And what am I going to call this now? Here is going to be the best model. So dot best model. I'll call it anemia bread model.pickle. Okay, and I'm going to print model saved successfully. Now, to load this model, this particular thing is going to take in a, maybe we could call it a file pathway. Okay, let me call it that. I'm going to self.file is equals to file pathway. And it's going to take in a file path. I don't want to use file path because I've used it previously. What is going to be now is going to say we're going to print, first of all, we are printing about to load our model. And then I'm going to print how many models do we have? We have so many methods right here. And so what I'm going to do now is w.load, and if each time we try to load this model, it has to take in file pathway. And we'll kind of maybe say we're gonna call it maybe model self dot anemia model is going to be equals to joblib dot load. So could just print model loaded. Okay, so this is going to load the model. Another thing we could do is we can just return, we can return this, but it's good we assign it, you understand? Okay, and then we can now do to perform a prediction. We can now say self can print about to perform some prediction. And we're gonna say patient is equals to solve dot x actually X test, if we're correct, dot iLack 0. And we could just make this 4, 3, or whatever, because it's a print. So we could see prediction is going to be equals to self dot predict patient. Then the probability is going to be self dot anemia dot predict proba of patient. Just give us the last one. And I'm just gonna print prediction and probability successfully done. That's that, guys. So we've created our class, and we can always reuse this code as many times as possible. All we just need to do is just to pass our pipeline, and automatically it will do what we want. That is the power of object-oriented programming. Okay, so what we are going to do right now is I'm going to perform some prediction right now. I'm still going to run all to be sure everything is fine, no issues. So we're going to now run our classes so that we can be sure that we have about more than 20 methods inside of this class. Okay, and we're definitely going to be performing some instantiating this class. So the first thing I'm going to do, I'm going to call this anemia. I'm going to call this class anemia, and I'm going to refer this to the anemia model. So just be careful. This anemia model here means, okay, let me just call this spread model so that it will be easier to differentiate. And I'm just going to call this spread. So I'm going to run out everything. Everything is okay, no issues. And so this model refers to this class. And I could decide to rename the class model program. Let me call it an anemia model program. I think that is fine. I think I should drop an error down there because I've got something that doesn't belong anywhere. I expect that. Okay, program. So I'll restart everything so that everything is going to be all right. No issues, no troubles. I think we could just make our way with all of this. Okay, we could just make our way with that. And okay, so this is our class. Okay, I dropped everything literally inside of one cell. So another anemia model program. So the first thing is to load our data set. This should take in something, and what should it take in? It should take in a file path and the sheet name. So yeah, of course it has to take in that, and I'm gonna call that So we can just shift our this way. So this is the file part. So I'm gonna call this anemia this, and I'm gonna say sheet name is equals to 0. That should work fine. Okay, it said anemia, this thing is not defined. We didn't run it. Let's run it again. And everything works really well, okay? If you want to view the data frame, all you can do now, we could do anemia.df, this df, and it's going to display the data frame, but that's not what we are doing. So we just want to run each method. So let's go line by line. Now, the next one we're going to do now is visualize the data frame, okay? So remember here, what we have is self.df.info and all of them, and all of that. So I could just go down. I'm going to be going up and down. So I'm going to call this. So I'm going to title this is uh, creating an object for the class. Okay, that's initializing the blueprint. Okay, so that's it. So here now I'm going to check our visualization. I'm going to say anemia.visualize data frame. And so of course it's going to let me do that. And you could see that about display head, it shows me that. It kind of shows me other information, parameters that I want to see. And of course, yeah, that's fine. And so we move to the next one. So the next one is to check missing values. So no issues. So we'll go back there again. We're gonna say anemia. Sorry, I couldn't spell correctly. I don't know what's wrong with me. Anemia dot check. No, not that. Check is in values, and I'm gonna run that. And of course, you could see that. You could see that there are no missing values here, but there are actually some, undesirable characteristics that's inside of our data. Okay. So the next one is anemia dots. So we're gonna go up. After checking, we'll check duplicates, then remove errors. So we're gonna anemia dot check duplicates 0. It didn't find any duplicates. Anemia dot remove errors. Okay. About to check duplicates. It checked about to remove errors. Errors successfully removed. Anemia dot now we'll go back there. And check duplicates, remove, drop non-values, and rename columns. So I'm going to say anemia dot drop non-values. About to drop, all of them is dropped. And then I'm going to say anemia dot what else after dropping non-values, or just to be sure, rename columns, and then okay, so anemia dot rename columns. About to rename is renamed successfully. Anemia dot encode and drop categories. About to encode. I just hope it doesn't throw any. Okay, you see that state is not found in the axis. And we need to kind of go back there because we are running it line by line. Mhm. Okay, states. States is not found here. You see, now watch our mistake. We did state instead of states. Okay, so see what we'll do now. We made a mistake. And see, this is states. We rename to state. Then I now said states. So I'm going to change it to S. I'm going to run it again. Everything should work. So we have dropped categories successfully. Okay. Now the next one is going to be anemia dot uh, mm, uh, create target, then visualize target. Okay, so uh, we go up and create anemia dot create targets. Targets about to create target created successfully. Anemia dot visualize target. That was saying visualize target from there. And I just hope, oh wow, that's beautiful. That is magnificent. That is phenomenal. It's phenomenal. Okay, so this is our target plot displayed successfully. And then the next one we're gonna do is anemia dot okay. Another thing we might want to do now is anemia dot visualize target and scatter visualize. That's to visualize the scatter plots and box plots visualize. Okay, let's go down quickly and just gonna down that anemia dot scatter visualize. Oh, it said blue name. Blue is not defined. And we need to go up and sort that out. Color blue and okay, now let me show you guys something. There's something we call RGB values, right? I could just say RGB to X or X values. Say X values, right? And this is for blue, right? So I could just copy that. And then I'm going to come here and I'm going to change it to this. And I guess this should. And then let's run all and see what's going to happen. Okay, let's go down. It tells us that what color quag must be color and sequence specs. Use the C argument instead. Okay, let me use that. C. Let's run all again. Okay, I think we need to change that. And sure, what we can do is, okay, name is not defined. I guess we didn't, wait, where is the, oh wow, there are a lot of methods. We changed a lot of methods here. Did we have blue this way? Was this how we defined it? Just to be sure, run or did we just drop it that way? Oh, we didn't wrap up the blue, and that was why we got that error. And I think that's going to, oh, beautiful. So we're trying to establish the relationship between children and children with anemia and pregnant women with anemia. And can actually find out that this is what it looks like. Well, that's it. So we could do anemia.box plot now to check, anemia.box plot visualize. Oh, wow. So these are the kind of only outliers that we have, there. And you could just see the values and all of that. I think that's working really fantastically well, if that word exists. And then the next one is we could do men versus women, right? Men versus women. And I'm going to say anemia dot men versus women. So let's say, wow. So this is kind of the relationship between pregnant women, non-pregnant women, and adult men with anemia. So you can actually see that it's kind of linear, or can actually kind of track a line here and all of that. I guess that was all. The next method is going to be feature engineering. That's anemia.feature engineering, then split. So anemia.feature engineering, okay, anemia.split, okay, that works. And we're gonna check another one. Then perform preprocess and then train model, okay? Let's see how that works. And I'm gonna say anemia dot perform preprocess course successfully, anemia dot train. Perfect, that trains our model. You can actually see that. And I think after train, that should be perform some visualization, because we wrapped that into a function. Then after evaluate model, we do cross-validate. So evaluate, then cross-validate. So I'm saying anemia dot evaluate. Wow, so this is what we call our classification report. I'm going to explain that, but let me perform cross-validation. Let me keep it here before I forget. So, wow, this is how our model is basically performing. We have an accuracy of 86.9, precision of 1.0, F1 score. You see that all of that. Now, what this means now is this is our true negative. So these are our true negative, correct? These are our false positive. These are our false negative, and these are our true positive. And you could see that this model still would see how it looks like during hyperparameter tuning. And while following our cross-validation, accuracy is still at 8 and all of that. That shows how our model is performing. And then after cross-validation, then we're going to do anemia tune, and then anemia tune evaluate, and then tune visualize. So that's what we're going to do. So I'll say anemia dot tune model performing hyperparameter tuning, is tuning it, and it's kind of tuning, and okay, still tuning, still tuning, still tuning, still tuning after maximum iteration was reached. Okay, it's still tuning. I'm gonna give some time. Of course, it has tuned it. So this is our tuned model. And then I'm gonna perform anemia.tune evaluate. Now let's check. So after tuning our model, our model increased, it increased to 95%. That is outstanding. That's really outstanding. And then we're going to do our tune, anemia, anemia.tune, visualize, and I think there's an issue here. Okay, figure, we mistakenly misspelled that. And of course, we're definitely going to correct that. And that was doing our tuning, just to say, where is, okay, that's here. And so we're going to go back. We've corrected that. I'm going to run it. And we're going to run that again. Okay, we should have, okay, we corrected it, but we didn't run it. Okay, so once you correct it, you have to run it. And then you have to go down. It has to work now. What? I have to run all. And so now that is going to work. Okay. And we have to let that run. Wow, so this is our ROC after tuning, and you can actually find out that it has displayed the plot. And so the next thing is definitely going to be to make some, after tune visualization, then we'll have to save our model. So we're going to call it, anemia.save model. Okay. So we're going to call anemia.save model. And model has been saved, so you can actually find our pico model here. And of course, the next one is going to be anemia.load model. It's saying that anemia requires one position. Okay, we should have passed that here, and I'm going to pass anemia pred model.pico. Of course, that should work. And then we're going to perform anemia dot predict. And that's that. Prediction done, successfully done. Oh, what happened? How come we didn't see what our model predicted? We're gonna go back. Oh, we didn't print it. Sorry, guys. So we're gonna print prediction. We're gonna say prediction. We're gonna print probability, and of course we're gonna get our probability. And then we're gonna run everything, and then we're gonna give it some time. Of course, that is definitely gonna work. And so we expect to have our final prediction of our model. And that is that, boiling out, and that's it. So it predicts that this patient doesn't have anemia and at 0.04. So that is going to be that, guys. I'm really, 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 really very excited to have had this session with you guys on end-to-end machine learning project via an anemia prediction model. And I'm sure you really enjoyed yourself. Of course, this code is going to be committed on my Git repository. And of course, this is actually what I'm going to be doing. I'm going to say git init And of course, I'm going to say git add, then I'm going to put that. So I'm going to say git commit, and then I'm going to say first commit. And of course, I am going to go to my Git repo, where I'm going to kind of show you how you can move this data set, move this to your Git repository to perform some prediction. And I'm kind of going to show you how you could do that. So you could just open here, and then you're going to search April 20 ml. Full anemia prediction model from scratch. And then you're gonna copy that, and of course that's it. And I'm just gonna come to my terminal here, and I'm gonna just paste this. I'll say git push origin man. And that, guys, is gonna commit this code to our Git repository. So we could just check it out here. I could just refresh this, and you can see our model is here, and all of this is here. If we want to kind of check what we did, you could just click on this, and it's going to give you all the code, that we've written based on this particular project. And that is definitely going to be that. So I want to say a very big thank you to each and every one of you who have actually made out your time to be part of this session from now and up to this particular moment. And definitely going to see you on the next one, of course. So very big thank you, and bye-bye.